So, hi, I'm good, and I'm here to welcome you to the Infinite Drawing Board, where I will explain some shit. Now, chances are you've heard of something like a blockchain or Bitcoin. There's been pretty common things in the last couple of years that have really kind of exploded and subsequently crashed. So, these are very important systems to know and understand why they work, and how they secure whatever it is they're securing. Now, in a standard blockchain, you have a block that contains some shit, some data, and then you have a hash of this block. So this hash meets a specific quality, like say there's a certain number of leading zeros followed by random numbers. So you're going to apply a function to this. Function of blah 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 equals this thing. And this has to meet a certain property. So you would hash this thing millions and millions of times until you get a hash value that meets your criteria for what you want to do with this. After you get this function, you then take this hash, and you put it into the next block. So this hash goes here now, followed by whatever garbage data you want. So this is a form of forward progressing security. So there's a direction for it, and you know that because of this long chain of hash values that have been stored, you can kind of guarantee that there's some form of security here. If everyone in the world is trying to do this operation at the same time, the difficulty gets very, very high. So you scale the difficulty up the more players there are in the system. So the more people there are, the lower the data rate stays the same, but the difficulty goes up. So as you do this and you build up this security, you can say that whatever is stored inside this block is secure. So now you can take this, you can take this and say like, hey, you know what? This is, secure. So whatever this is produces some type of story, for instance. And you can say like, this is a database now. So whatever is stored in here creates an ordered database of instructions. So for Bitcoin, for instance, this is a list of transactions from old value storage and being updated for whatever your transaction, like whatever you're forwarding these transactions to. For Ethereum, it would be like machine instructions. So there would be a machine instruction like call this function that was defined way back in the day, call this function again, do some other bullshit, define a certain function here, big block of data, and then some more regular transaction stuff. Then, define some weird bullshit. So, you can kind of think of like smart contract systems as a very general purpose format for what a blockchain can secure. So you need the security to be here so you can verify that whatever you have in your local database is correct. And that's really all you really need to know. Basically, you can replay the blockchain in order to get your own local version of reality that you understand is correct, and that other people will also agree with you, and they will also say it's correct. So by consensus, everyone has agreed that this structure has secured this data. Okay, that's simple. So I'm going to say we can take the same type of use case and make it a little bit better. Or we can take the same type of format and restructure it to solve a different use case. And the use case I'm saying is we could use it to create a new version of the Reddit experience, where people can say, have just a big, splash page, and then there's, a link, a topic, a picture, an image, some bullshit, and then you as a user can go in and vote on it. Okay, so you can apply an upvote or a downvote, for whatever you want to do. And then you can rank all of these topics by, how many upvotes they've essentially gotten, like how much of the coin share has been put into each one of these things. So, how can we kind of construct this in a blockchain-like format? So, the solution I've come up with is where you start off, you can start off basically anywhere. It doesn't really matter. anyone can make a network and have people join it. You understand it's secure because of the overall security that's been built into it. So you can kind of think of the, your voting power as how much work you've recently supplied into this network. So you have a block. This has a list of transactions on it, and these store some type of value with an account on it. So these have some type of account ownership. I could color all this shit, that would take a lot of time. So, there's some type of value, like 10 is stored here to account number, FAF or something. And each one of these has some type of information. And then there's also the owner of the block who produced this thing, and he also has some ownership of whatever coins are in this block. So you can kind of think of the owner of this block as having their own little ownership inside of it. So, now, this is pretty simple. It's exactly how old blockchains work. So, say at a certain point in time in the future, a person can produce a new block. So I produce a new block. Now, instead of having a kind of like a, what would that be? So in Bitcoin, for instance, the difficulty is raised if the data rate gets too high. In this version, I'm saying that difficulty is constant. So the difficulty I'm kind of shooting for is 4 blocks per day per machine, whatever that's kind of going to be defined as. So 4 blocks per day per person on this network. And a block size is 64 kilobytes. So you can take not a huge amount of transactions, but a couple of them, and forward them into your own blockchain, or into your own block. So I'll take one from here, there'd be like some previous block out here, and I could take a transaction from there and forward it to here. Now, I'm going to say I can take any transaction I want from any previous unclaimed transaction. So the reward I get for doing so is a decay amount that's based on whatever the value is and where it was forwarded to from the previous point in time. So here's our current time 0, and this would be like -t and -2t, And we're going to say like per time value, or per time that's been defined, there's going to be a half-life decay associated with that. So say there were 10 coins stored on this transaction. After I forwarded to this block, there's now 5 coins associated with this account. So this becomes 5 coins on this account. The decay I can now claim for myself. So this is sent to the block owner, along with this, and whatever else of the transactions that I've claimed, until essentially this block is full. And then I've claimed, some big reward for creating a block. So this is the general idea of this, and it kind of spawns an interesting type of property. So, because anyone can produce a block at any given point in time, they simply produce a block, label a timestamp to it. The time doesn't even have to make sense. You could put it in the past or in the future, whatever you think the network would accept. So say another block is made, there's some owner here, yeah, and they claim a couple transactions. So this thing goes here, and then there's another block, and another block, and another block, and another block. And there's many users, okay? So the idea is you have about between 100,000 and 1 million active users contributing machine power into this network of blocks that's being created. And as more and more blocks are made, you have this interesting web that's kind of built up. So this goes here and here and here, and maybe this goes here, and so you can see that the network becomes very out of order very quickly, and it builds this heavy, deep meshing web of transactions. So this is kind of a nonsense, Pepe Sylvia type moment where you're like, what the fuck? And it has no real purpose. The security of any given transaction is exceedingly low. It's hard to keep track of what's been forwarded. It's hard to keep track of really anything. But the idea is that anytime a block is made, a person will selectively take the previous unclaimed transactions, which have not been forwarded, at a very far history. So the farther back you go, the more decay has passed, which means the valuable transactions are always in the back of the web. So at some point in time, you're going to have this big old structure containing all these blocks. And you might say, like, okay, there's, say, like, 20,000 blocks within this structure. So at 4 blocks per day per machine, so you have, what the hell? I'm looping around myself. So at 4 blocks per day per machine, say if we have, like, 200,000 blocks over 4, so this would be, like, what, 50,000 or 5,000, 50,000 days of machine time. So this is like 50,000 days of machine time. Days. Days difficulty, I'll say. A wall or something out here. Yeah. Diff is 50,000 days of machine time. So you could say, like, this web, for a person to reproduce it is very, very difficult. A singular person is going to have a hard time remaking this. So you believe that this is true based on the expense put into it. Okay? Now, yeah, I'm going somewhere with this. Now, as a person claims more and more of the same blocks, so the person claims more and more of the same blocks, like say I claim this one here, and that's mine, and then, I claim this one here, and, this one here, and here. You can kind of see that after a while, the coins that I have are going to kind of build up and accumulate. So now there's some coins up here, and that gets forwarded into this block, and, like these are all mine, and then this is kind of accumulated here. So at some point you could say, like, the more work that's been put in by one person, the more coins they control. You would kind of selectively choose the ones that always give you the highest reward, which might not always be the ones that you actually own. So this is an interesting game you can play with a lot of people simultaneously in order to distribute voting power or knowledge of how much work a person has put into a network. So now you can use this to distribute voting power to each user on the network. So now I own a lot of coins, and now I can put in a block into the system that defines that I'm going to use my coins, whatever coin total that may be, in order to make a post. Some type of link, data, a hash to a file that could be then identified off of the hash to a file that could be used to identify whatever that file actually is. So whatever you would want to do, whatever data you would want to share, then you could kind of vote on it to have other people promote it in their own list of rankings in order to kind of see what it is. So, like I might like this certain picture of a cat, and I'm so certain I like it that I'm going to put all my coins into staking, like, here, this is the shit I want to show the world. And then the world can see this and be like, hey, this guy's picture of a cat is pretty cool. I'm also going to stake my coins onto it. So another person could take, their old block of coins, and they could define, I want to stake this onto here, and they would define that in another block in the future. So now this guy's like, I have all these coins that I want to stake to whatever this is. You could back reference it, or figure out some way of doing all these references to make sure they kind of work in this network that's been built. So then after a whole bunch of people start doing this, you can kind of recreate this type of Reddit-like structure where there's a list of posts, and then you have their associated rankings with them, and you can sort that by whatever you want. So this is an interesting idea of how you can make a blockchain-like system kind of fit a real-world use, and also using proof of work in order to make this kind of work. The network will naturally fork when the data rate gets too high, so you can expect there won't be one singular network, and there shouldn't be a singular network. There should be many, many different types of these networks all existing kind of simultaneously on top of one another, but not referencing each other, obviously. So, anyone can join it. Say you join at this period in time. At some point, every previous transaction from before this point in time will be forwarded into the new web of data. Stop moving around. Into this web of data. So if you join the network at this time and keep track of all the new blocks that have been made, you don't even have to know what all this knowledge is of all the old blocks, because all the data, or all the coin totals of every single previous transaction will eventually be forwarded by someone who is on the network at this time. Because there's a very high reward for doing it, because if someone forgets a transaction and one person has memory of it, they can forward it and be like, hey, here's an old transaction, I'm going to claim all of it. So in order for this to work, a couple rules need to be applied. So rules. Yeah, let's just go through here. So rules. The minimum value, so minimum coin, or minimum amount of coins you can have is 1. If a transaction contains less than 1 coin after it's been forwarded, the owner of the block, whoever's forwarded it from, can claim the entirety of the coin. So, if the coin totals get too small, like, we don't want to remember, someone's old-ass account that contains, like a billionth of a coin. Like, that would just be garbage. We get rid of all that. We don't care about you. You're too poor. Get rid of that. Another thing you can do to kind of increase the security of the network is say, like, if you want to post a block, you have to reference 4 previous blocks. So each block references 4 previous blocks. So every block has to reference 4 previous blocks. Dink, dink, and then like dink. So if every block is forced to reference a certain number of previous blocks, it naturally builds a type of small world network. So the directed acyclic graph that this is making becomes very densely linked. It's very unlikely that there's going to be like some loose thread around here that isn't kind of linked back into the greater, or isn't then security backed into this web that's being very tightly woven to hold all this security all together at once. I've worked through all the attacks you could kind of put on this network, and I don't think there's anything that isn't possible to be beaten. So for every type of attack that I've thought up, there's some way the network figures out how to make the attack not actually an attack. So the minimum coin value on any transactions being forwarded is 1. The block size, so size, that's 64 kilobytes. The, man, my writing in VR is horrible. It's weird, right? Whatever. So block size 64 kilobytes, minimum coin value 1. Links is greater than 4. So you have to have 4 or more blocks linked into it. What else do you need to have here? Oh yeah. So for every block that's being linked, you have the current point in time. So you have, let's see, the time delta. So the time difference between the oldest block you've linked with the newest block you've linked. So the time difference between the newest block, or t now, minus t of new, this, that's 2 times. That's how far back you can reach. So if you go into the recent memory, so say you're this block, and you want to claim a transaction from this block, there's a tiny amount of time that's been kind of, between these 2 things. So if you want to claim transactions from all the way over here, a really old transaction, you need to be able to claim a transaction, or you can't claim any transactions from this block. You have to go farther back and start claiming stuff from over here before you can go claim these really juicy transactions all the way in the back. This prevents like a security-backed kind of future-proof block attack that I kind of thought up, which could be possible if you were really, really trying to kind of tear the network apart at huge expense to yourself. So with this rule set, I think this Sylvia network becomes kind of secure. Yeah. So I think I ran these numbers before, and I think with these numbers on this network, if you had 1 million users, so 1 million customers, so 1 million machines running this, mining it, whatever, 1 million customers, users, whatever you want to define this as, the data rate is 2 megabit per second. 2 Mbps. So this is a pretty good target. You have to be connected at all times, obviously. Well, not all times, but most of the time you'd have to be connected to the network. And yeah, this is not an insane data rate to kind of, try to keep track of this network with. It's actually pretty reasonable. At least it's going to be very reasonable, even in like really strange third world countries. 3 to 5 years from now, when this solution becomes maybe a lot more in use. So this is a good way for distributing network voting power to actually work. You believe it's true because the cost expended into it. The thing this does, so the main benefit of this is that it's immune to bots. Or it's not immune to bots. Bots can still post and do whatever they want. They can upvote and downvote. But everything on the network has a cost associated with it. So this idea of free botting, where you could just have, a million different people, say I'm this guy, right? Like like, I'm this guy. This is me. And then there's all these other people. They're not even like worth drawing. There's only 2 people on the internet after all. All these people are over here, but they're actually just on this big old machine. They're all actually AI program that's kind of running in the background, upvoting and downvoting everything they would ever think, and being controlled by somebody, something, some idea, corporation, person, government entity, some jackass. On the open internet right now, you have really no good way of identifying shitty users. But in this system, it doesn't matter who's a shitty user because they're actively updating, maintaining, and broadcasting the network to all the other legitimate users. And they're also doing it at extreme cost to themselves. So this is an interesting way of making a cryptocurrency system. So I think in order for this to be built into software, I think it'll take, I will post a 100 Ether bounty for whoever makes this software, or 50 Ether bounty. So I have 100 Ether to give away for whoever starts making this crap. 50 Ether goes to whoever can make the first implementation that makes this shit work. I don't really care. Make it, post the source code, I'll give you 50 Ether for it, if it seems like it works at all. The second person to do it, 25 Ether. The next person to do it, 12 Ether. Yeah. And that would be kind of like a fair way of bountying this off. There's probably a lot of initial blockchain software projects you can start from in order to kind of have a decent way of, or a decent start on it. Otherwise, we can try to raise funds between 50 to 1,000K. So somewhere between this amount of money, and then we could either, on the low end, we could say, I'm going to pass this project off to a bunch of college students who can make it in their spare time and throw money at them because you can pay them very, very small amounts to do cool things, versus a lot of money where we could hand it off to an actual software development company and provide support for it for like 3 years in order for this to be made, and then maybe patch all the bugs and anything else that might be a problem for it. So yeah, this is the idea. Yeah. So interesting idea. Tell me what you think in the comments. I think it's kind of important that this gets made because currently bots and fake user accounts online are kind of dooming a lot of things for our regular ranking systems. For instance, user reviews are kind of a big one. So how do you know if a user review is legitimate? You kind of don't. But if we forced everyone to be paying like $1 to post a review, no one would be claiming this dollar. The dollar would literally just be fizzling into the into this space of nothingness, just burning electricity and machine power. But the cost associated with it is good, because now people can't post lots and lots of bullshit freely, so it shuts up loud users. A person can still use it, but they can't post excessive amounts of things unless other people start donating their coins to that user. Yeah. Anyways, I'm Gouda, and if you enjoyed this, and I will see you next time. Feel free to steal any of this, make it, I don't care. Use whatever idea you want out of this. I don't give a shit. It just needs to be made. Some network like this needs to exist that does not have, you can't buy in historical voting power. Also, interesting thing to note, your voting power is actually related to how many blocks you've recently mined. So the people who mine the stuff all the way back in the beginning don't actually have any value on the current network. So as time progresses, these old accounts become, they fizzle down to like 0 value, while these new accounts kind of accrue all the old value. And then, for an interesting kind of thing you can do with this, you can replay this whole blockchain from the initial time all the way back to the current time and see what the kind of Reddit front page would look like at any given point in history, granted as far back as your history would store all this data from. So you can now replay Reddit at any given point in time. So I don't care who you are, you want this network, because if you're a researcher, a university person, some corporate guy, some shady government entity, some jackass, you want it because you get access to all of this old data that you can use in order to empower your own decisions. Because now there's an honest way of understanding how people vote and what their interests actually are. Yeah. So I'm Gouda, and I will see you next time.